So today's factoring review has two versions. There's a version A given in class, as well as a version B given in class. So the first question for both versions was the same. So after you watch that first question, feel free to jump ahead to the next version. I'm going to start with the questions in A, and then I'll move to question B. So in both versions, we need to start with question number 1. And this is just asking us to think about the process before we go do it. And it's asking us to look at our factoring flowchart. So according to our factoring flowchart, whenever we factor polynomial, we want that leading coefficient to be positive. Now, because we want that leading coefficient to be positive, this means when we're checking for the greatest common factor, we might need to factor out a -1. And all I was expecting here was that you were going to your factoring flowchart. Here's a little picture of what it would have looked like. And in that upper right-hand corner, the answer to that question was right there. So now we're ready to factor. I'm going to go through the problems in part A first, and then I'll go to the problems in version B. So when we're factoring polynomials, as it said in step number 1, we want that leading coefficient to be positive. Right now it's negative, so I'm going to factor out a -1, which would be rewritten as -1 times 7x plus 12. And then from here, we can factor this polynomial with a leading coefficient of 1. We don't forget our GCF of -1. And then the numbers that would add up to 7 and multiply to 12 would be +4 and +3. So this is our final answer. If you forget your GCF, you will get it wrong. So don't forget your GCF. Looking at the next one, the leading coefficient isn't negative. So when I'm looking for a GCF, I'm just going to look for the GCF of the numbers, which is a 2. So the GCF of a 2, so we're left with x squared plus 3x minus 18. So then we're asking ourselves, after we carry down our GCF, would there be any numbers that would multiply to -18 and add to +3, in which case we would choose x plus 6 and x minus 3. And that would be our answer. Again, without that GCF, you will get it wrong. So you need to include that GCF in your answer. When we look at letter C, we're going to look for a GCF, and the leading coefficient is negative. So in this case, I am going to pull out a negative. The numbers 3 and the numbers 5 don't have anything in common, but I could take x's from both of those. So I'd be able to factor out a -x squared from both of those terms. So if I divide by -x squared, I'd be left with +3 minus 5x. And that's your final answer there. Looking over at D, I'm checking for a GCF of 3, 14, and 5, but it doesn't exist. But I do note that the leading coefficient is a negative number, which is not what I want. So I'm going to factor out a -1 as my GCF. So I'd be left with 3x squared minus 14x minus 5. And now to factor this, if it starts with 3x squared, I know one parentheses has a 3x in it. The other one's going to have a 1x in it. Now it's my job to figure out what numbers could possibly multiply to 5. And of course, those are just 1 and 5. So I need to do a guess and check method. Do I put the 1 there and the 5 there? Or do I put the 5 there and the 1 there? So what I'm looking in my head is if I put the 5 here and the 1 there, that would allow me to make a group of 15 x's and a group of 1x. If I had 15 x's and 1 x's, if those 15s were negative, that would combine to -14x. So I want to put a negative in front of the 5 and a positive in front of the 1, and there is my final answer. Now, if you did version B, or if you didn't do version B and you're just looking for more practice, this would be a great thing to go practice. So obviously question number 1 is the same, and the problems are very similar in regards to how we approach them, just have different numbers. So when we approach letter A, we're always going to check for a GCF. So -1, -8, and -15 don't have anything in common. But I do notice that the leading coefficient is negative, which is going to force me to factor out a -1 first. So after I factor out the -1, I carry down my GCF. I have x squared plus 8x plus 15. So then after I transferred out my GCF, I'm asking, would there be any numbers that would multiply to +15 and add to 8? And of course, that would be +5 and +3. And again, if you don't include your GCF in your final answer, you will be wrong. And that's a silly way to lose all the points, but it's very important. When we approach letter B, we're going to look for a GCF. 2, 4, and 48 are all divisible by 2. Now, the leading coefficient is already positive, so I don't need to take out a negative. So after I pull out a 2, I'd be left with x squared plus 2x minus 24. So in my final answer, I carry down my GCF. And since the trinomial that's left starts with x squared, I know it's going to be an x and an x. And the numbers I would multiply to negative 24 and add to positive 2 would be positive 6 and minus 4. So your entire answer is 2 times x plus 6 times x minus 4. Letter C, I'm going to look for a GCF. Negative 5 and positive 3 don't have any common factors. So I'm just going to pull out some x's. So you could take out an x squared or a negative x squared. Either one doesn't matter. And after I pull that out, I'd be left with 5 minus 3x. Or you could have written it as x squared, and then you would have done negative 5 plus 3x. Either one of those is fine for me on this one. When we approach letter D, we're going to check for a GCF. Negative 7, negative 4, and positive 3 don't have a GCF. But as we wrote down in our first question, when I notice that the leading coefficient is negative, that's going to force me to factor out a negative 1. So after I pull out a negative 1 and I divide all those terms by a negative 1, I carry down that GCF so I don't lose it. And then what's left in parentheses would be 7x squared plus 4x minus 3. Now when I'm factoring this, because my trinomial that was left over started with a 7x squared, I know that my factorization will start with a 7x and a 1x. And I'm asking myself, what numbers would possibly multiply to 3? Well, that can only be a 1 and a 3. So it's my job to figure out if I want to put the 1 there and the 3 there. If I did that, 7x times 3 would make 21x's. 1 times x would just make 1x. And I couldn't get that to be 4. So what that tells me is that organization was wrong. So I'm going to switch around the 1 and the 3. So I'm going to put the 3 here and the 1 there. Now when I do that, which I'm going to indicate in green at this point, 7x times 1 would give me 7x's. 3 times x would give me 3x's. And those would be negative 4x's as long as the 7 was negative. So I got the group of 7x's by multiplying 7x and the 1. Well, the 7x here was already positive, so that means this 1 must have been where the negative came from. So I make that a negative and that a positive, and then this is our final answer.